Hello, my name is Elliot Ramos, and I will be presenting my problem situation for statistic. This was factors that affect the sale price of a car. And well, first off, we did a multiple regression in the end. What does this mean? Basically, a multiple linear regression is a statistical technique that uses two or more variables. These are independent, and we see how they each relate towards a dependent variable. In this case, we will be using x and y. Y is a dependent variable, x is an independent. Basically, what this allows us to do is see the variation in the model with each relative contribution of coefficients for each variable. And basically, these models can take either a linear regression model or nonlinear regression models, as we will see in each specific case. For this particular situation, we will be analyzing the data from a Camaro car brand regarding the price of depending on the year, model, mileage, condition of the car, if they only had one owner. And we are going to use a linear regression first to analyze two cases, and then multiple linear regressions for uh, getting all of our variables analyzed. What we seek with this is to see which of the models is the most precise and has the best data to see if we can apply this to other car models. Well, first off, we will start with our 31 data samples. Here we have the Y, which is the price, and then all of these are going to be our X variables. Depending on which case we will analyze, we will have either 1x, 2x, or infinite number of x. For our first analysis, we will do the relationship between age and price. As you can see, we have sale price as our y and age as our x. We did here the analysis. We will come back to that later. First off, I want to see some graphs. Here we did a linear regression, exponential regression, um, logarithmic regression, and here we have an coefficient regression. Uh, Basically, what we wanted to denote here was these equations and difference in r squared. R squared basically in this context means if we multiply by 100, what is the percentage of certainty we have that all the variance in y is explained through this model we have. For example, in the linear regression, we have 0.76 as our r squared. Exponentially, we have 0.856. That's a lot higher. Oh, but here we have, for example, in logarithmic, 0.8689. So that's the highest we have. Yeah. Here in the x squared x plus b, we have an 0.85. So as you can see, the best model you could say that one could use would be the logarithmic. Logarithmic is mostly used for these kinds of expressions where it's depreciating value over time, or depreciating something, like uh, microorganisms, all that stuff. So that would be like the most useful, but we cannot calculate here, for example, the all the other aspects that are needed for this. So we're gonna stick to the linear right now. So for example, in the linear, we had an r squared of 0.676. This is the same. However, what changes? The correlation value. The correlation value, what does it indicate us? It indicates what is the relationship between the x and the y values in order to form this sort of line, statistic line. The closer is to 1 or to -1, the better is at modeling our relation, a real relation between the variables. So here we have minus 0.87. This means we have a really strong relationship between the two. As you can see, really the line is very clean. It passes almost all of the points in a very neat fashion. And it's negative, well, precisely because of this downward slope we are presenting. This can also be very clear when we analyze the coefficients of the possible range of coefficients for this equation, primarily centered at this number right here. Sorry, this number right here. So basically, what we have here is that for this model, the the range of possible values for the coefficient that will later be multiplied by the amount of years a car has is between minus 46,308 to minus 30,060. So that gives us a whole amount of possible values for that range, all in the negative slope, in the negative side of this. So it will always follow this negative 10 slope. And basically, we can say that within this range, there's 95% of confidence that our coefficient is in that value. We did the same for mileage and sale price. Basically, we also studied linear regression, exponential, logarithmic, and squared regression. As you can see, I think we had almost the same. Yep, logarithmic is the best one to use, as I explained earlier. I think logarithmic explains really good this depreciation. And in the case of our regression models, well, you can see that we also have a negative 10 negative slope, and yep, that makes sense. Our limits are also on the negative side with medium in this little spot, minus 1,844, and all the inferior limit is minus 2,266, and the upper limit would be in minus 1,422. These are all the possible values for the coefficient of mileage in this equation here that explains that the price would be from minus 2,266 to minus 1,422 x, being this mileage, plus our coefficients for the interception. That would be these numbers right here. With that, we can create like a really good model that would encapsulate 95% of the possible values that affect y. Now, this is where it gets interesting, the part where we get to multiple linear regression. Basically, what happens in this part is that we are now going to try to create a model using age and mileage and their correlation to y. For this, what do we basically have to estimate? Here we have no graphs, mainly because when we try to model more than two variables, the graph ends up being very sloppy in Excel. We would need a bigger plane, a 3D plane, in order to model this type of graph, where we would get a plane as our possible um, function, you could say. However, what we can calculate is the coefficient of correlation and our determination coefficient. Our determination coefficient, as said earlier, explains the variance in basically the certainty we have of this the, of the price being estimated by the x values. We have basically a 81% variation explained by the mileage and the age of the car. And uh, an interesting point here is that normally this correlation value we calculate it in Excel using the Corel function, as Excel only gives us the positive values for the correlation coefficient. However, in here with the coefficients of the variables, we can see that they are all on the negative slope. So this would mean that we have similar to defined here, only with different planes, downward slope, meaning that this correlation, sorry, that this correlation value would be incorrect. Actually, it would be more like this, but negative. So this would be the true correlation value, as these values most likely will fall on this negative slope. That was just something important to notice in the analysis of Excel, because, as I said, Excel doesn't give us the positive values for the other ones. We calculate it using the Corel function. However, when we have more than one column of x variables, that function will not work. What else is there important for this? Mm, Well, as I said earlier, actually the ties between these two independent variables to the y grow in comparison to them being apart. As you can see, we had 0.87 and minus 0.85. However, here we have 0.9. That's a little bit more correlation with these aspects, meaning that the more variables we add, the better analysis of a line or curve you could say we have. However, once using this r squared adjusted, we can see that there is a slight difference here. This is most used for when we have multiple linear regression, as this explains the real variance you have of one single variable, and then with the other one, and the real say the real variance you have of the y with the two variables, not just with the r squared normal, because that value is mostly important when you have a single variable. Although it is useful in more common statistics, they like to use r squared adjusted. Finally, we get to, I can't, Well, finally, we get to our last model. Here we did all of the matrix of data we had, the five variables and the five x variables or dependent variables in our the five independent variables and our single dependent variable. As I said earlier, with more variables, our correlation coefficient increases. Once again, this would most likely be negative, as we had seen in previous examples. The slope of this model in any case would be negative, as we are always kind of depreciating our cars with the passing of time and other aspects. As I said, here the coefficient of determination and R squared adjusted is also a coefficient of determination. Um, really, they have little change. However, it is important to consider these aspects. For example, right now when we are using five variables, um, the little changes in what is the area of variance we cover, and not be completely guided by, oh, we have an 89% of variance of y explained by these five variables. Just considering that. And well, this is where it gets kind of tricky, considering the coefficients, because, for example, age is an important aspect of our function because it covers a range of negatives, as I had said earlier. Most probably the correlation coefficient would be in the negative area. However, the next one targets from minus 1000 to minus 1020 to 192. That range actually contains zero, so that is, as zero is a possible value for mileage, um, that coefficient of mileage would be zero at some point, and thus making it not statistically important for our model. The same I think happens for the next one, average condition. Yeah, that doesn't really matter to us in this model because of that zero. And the one owner also doesn't fit the, the restrictions. The one that does and catches my attention is actually excellent condition, because this is a positive actually coefficient, and it's just what's important is that this one does have a statistical value. However, as it is an excellent condition, and this condition can only have like a yes or no answer. It's either a 1 and you multiply it by the range of these values, which will give you to a certain limit, like the maximum you could have is 111,421 as a sum of the value of the price of the car, and you could depreciate it with the mileage, however much you want, along the miles, because this is the important part, as one could see that, oh well, I have a positive, yeah, but that positive is not really having a real great impact on the final price. So it is really important to to consider all these aspects. For example, when um, analyzing this coefficient correlation value. Um yeah, I think that's basically it for explaining the all the models we did. And what do I have as a conclusion? I think that it is important to to consider what you are analyzing apart from all the numbers and data you have to really interpret the information in a real uh, background, you could say, way, where as I had said, some of these data make more sense when you see like a real problem situation, in the sense where, well, a car probably won't like gain more money when it's not brand new, unless it's like a really good vintage and it's like in perfect mint condition. That is a case where I can see like the excellent condition variable really sticking out. However, that is not really the most common type. So, especially for this case where we were analyzing the 31 um, linear single point values of the Camaros. Camaro is not really like a vintage brand, so I couldn't really see that situation happening. However, as I said, it does have a real impact. But another important aspect to consider, for example, in that is that those are categorical variables where it's very subjective to like know. How does one gain like a yes or no? Um, However, this does have really good applications in real life. All this part of creating multiple linear regressions. Uh, from what we can see, multiple linear regressions really boost up the amount of confidence you have in encapsulating all of the little aspects that define your final dependent variable. For example, in this case, it was a price, but it could be for grades, or even in the more industrial, in the case of um, how many cars get towed to your stations, quality control. There are a lot of factors that are really good to calculate with multiple linear regressions. However, the outcomes you have are really subjective to the perceiver of the situation, because Excel can literally just go like to data, analyze data, and regression, except you pick your like the y variables, you pick your x variable, your I messed up, x variables, you say like, yeah, 95 confidence, and then you put like, yeah, that's good, but just let me check that one. Yep, all good. Okay, literally you're gonna get the data. The data is very easy to like extract. However, more than the data, the statistics are very easy to extract. But what's important is to analyze and to really know what it is that you are calculating. For example, I can see like just a lot of numbers, and it's like, what is that? What does this mean? Like, what I explained there earlier, like, oh yeah, that's like a good number. Look, I got a positive. Yeah, but you got a negative over here, so all that range will not really give you any useful information for your model. And well, in the end, I think that the more models we can see, as I said, like in the introduction, there are more models other than the linear regression model, and I am particularly um, looking forward to being able to explore these exponential and logarithmic models, which I think like suit um, some of these variables better than a linear model would. And I don't know how much we could boost up our R and R squared because of it. As I said, considering that the more variables you choose to analyze, the bigger the correlation of these with the Y variable will be. I believe it can be a great opportunity to explore this model. And also some categories like the one owner, I think don't really have a great impact on the model, and or condition like average condition really doesn't tell me anything, like if I'm buying it, because it's not like bad, but it's not excellent. It's just there. So I would eliminate, for example, this one. Maybe this can be useful for resale cars, but not for brand new ones. Um, so yeah, there are a lot of like little details that once one analyzes them, it becomes clear that not every part of this problem situation was important to analyze. Um, but yeah, thank you very much.